right, so here we go. Finding inverses for functions right here. This is going to be kind of, some things that we've had in the past here, but we're going to have to use this idea of natural logarithms and then natural number e to figure this out. So, guys, what I would probably do here for finding an inverse, remind me what my rule again is for finding inverses.
Switch X and Y.
Yeah, if I would cross this out and say this is kind of like what kind of a value right here first. This is like saying y equals 6 plus natural log of t, isn't it? So what I'm going to do, I'm actually going to switch y and what else around right now. And then what are we trying to get alone? Okay, so this is kind of a tricky one. Let's do that. Let's rewrite this as, let me get rid of this piece. I don't know why that's there. Let's start at square root. Hate to waste that, but I did. All right, here we go. So we're going to call this, to find the inverse, we're going to say t equals what, kids?
6
Plus the natural log of what?
Y.
Yep. So this one's kind of tricky, like I said. So I'm going to walk you through this here. What do you think the first step is in trying to get y alone here to find that inverse?
Subtract 6.
Yeah, so we've got t minus 6 equals natural log of what?
2.
All right, kids, here's the deal. This is where things get tricky. In order to get the y alone, what's the inverse of natural logging something?
E.
E, right? E and the natural log are kind of inverses of each other. So what we're going to do is we're going to take both sides and we're going to make them a power. We're going to say, you know what? Let's take e raised to the power of what?
2 minus 6.
That's going to equal e to the what?
E to the natural log of y, or just e to the y, right?
Yep, e to the natural log of y.
And then just be y.
Yeah, that's one of those identities right there, or one of those simplifying rules. The e and the natural log are inverses of each other, so what do they really kind of do to each other? Kind of go away, and what's that leave us with up here?
Y equals E to T 6.
So what's our inverse function, kids? Say f inverse of t is equal to what? E to the... Right? You guys okay with that?
Imagine being good enough at math, just look at that equation and saying the inverse is t equals e to the t minus 6.
And you know what? With enough practice here in this section, you'll be able to do that, honestly. So, all right, so here's what I'm going to tell you guys to do. I'm going to have you guys try finding the inverse over here on your own. Okay, so go ahead. Probably want to assume, get rid of that f of t notation up there. Probably put one up there first, kids. I want to cross that out and write y equals. I want you guys to take a minute or two and try and find the inverse there. So that's what we come up with. But look at these two examples on inverses here. Guys, originally, the original function had natural log in it up here, didn't it? Which meant the inverse had to go back to what? E. Up here we started with e, which means the inverse is going to involve a natural log. So yeah, I like this form right here. In terms of how you want to do it, I don't really care. My concern is you can come up with a function. Again, if you're dividing by 0.25, same thing. Did anybody call it like natural log of t minus natural log of 28 at some point? Could I have done that right here and said, oh, this is the natural log of t over 28. Could I have done natural log of t minus natural log of 28 there also, all times 4? Or I could have done natural log of t minus natural log of 28 all over 0.25. So some of your answers when you're doing these inverses, is there a possibility that they may not look exactly like one answer you're going to see in solutions? Is it possible? Okay, you guys just need to follow your rules and work to, so once you switch the y and the t around, work to get y alone. And once you've established that y is alone, depending on simplification rules, yours might look a little different, but actually be the same exact thing. If I say 1/2 x and Grace says 0.5x, who's wrong? Neither are. Half x or 0.5x next same thing, okay? All right, how many were on the right path? Give me the show of hands there. How many were at least on the right path with that? How many said, well, I went from E to natural log or something somewhere within that process? Okay, that's what you need to understand. That's how they're related, okay? All right, last example here. Let's talk on this one. I really like this example. It's pretty cool. I screwed the paragraph up, so let's fix this. It says the population of Iowa was what? Was 3.76 million, or 0.76 million. I forgot to tell you what year that was. That year was, guess when? Anybody have a guess?
2013.
Close. 2012 is when the population. Now the population in 2017 was 3.144 million. It says assuming what there, kids?
Exponential.
Assuming exponential growth rate here, kids. Write a formula for the population of Iowa as a function of time for both exponential forms. Use both to predict the population of Iowa. Do I have any volunteers that maybe want to mess around with this one on the left? P equals P sub O A to the T.
Got it.
Who wants to mess around with the new form? P equals P sub O E to the KT. I think one thing we should revisit here, and I don't have it written down in the notes, but we had this core concept. We said that in the core concept, A over here on the left had to equal what on the right?
Okay.
E to the K, which meant that K then would become equal to what? Right? All agree? I have a better idea. How about we try and talk about this one on the left before we head off to lunch together? Is that fair?
Yep.
Okay. What was the initial population in this problem?
3.076.
So I know it for P sub O, I can plug in 3.076. Okay. Do I know the A value? I do not. How much time elapsed from 2012 to 2017?
5.
So when my T value is 5, kids, help me out. What's the P value have to be? What was the population 5 years after it started?
3.144.
Okay, so I'm gonna need some help here, kids. We've got to figure out that A value first to write a function here. We need to know the A value. So you guys know what to do here. What am I gonna do?
1.26 to the 5th power out to there.
To figure out what A is, wouldn't I have to get A to the 5th alone first? So what do you want to do to both sides? Say it again, Sterling. Perfect. Who has a calculator handy for me? Who has a calculator handy for me? John, are you punching in 3.14 divided by 3.076 right now?
Yeah, I got 1.022.
Okay, so whatever that is, 1.022. Leave your answer in the calculator so that it fills up that whole window. Now, what power do I want to take that to, or what root do I really want now? I want the 5th root of that answer that you just had. So take the 5th root of that answer. Tell me what A is equal to, kids.
0.1765.
It has to be 1 point something.
1.004.
1.004?
That was too high.
I like 1.004. It's what we came up with yesterday in 6th hour. So we're good. So guys, this function right here, we'll pause here before we go to lunch here in a second, but let's at least get the function down for this initial form that we've known. So we would say my population P is going to equal an initial population of 3.076 times
1.004.
to the,
T.
I'm going to pause that here, kids, formula over here for exponential growth. So writing out of the form P equals P sub O E to the KT should be pretty easy, kids, because remember, A is equal to what, kids? In this form right here, what would A equal over here? what do we say, what do we say K was really equal to, kids?
Natural log of A.
Absolutely, K is equal to the natural log of A. So, that said, do we know the A value over here on the left?
Yeah.
So do you guys agree that K is really equal to the natural log of what value? Alright, somebody wanna run that for me real quickly?
Point 00399 2.
Point zero zero
I don't know how you wanna round that.
3 what?
3992.
Four.
Is it if I go .004?
Yeah.
Okay. So help me out, kids. We would say for this right here, P then is going to equal 3.076, because that was the initial population in this problem, wasn't it? Times e to the what?
0042.
I want to show you something about these here, kids. Both functions show exponential growth. What's your reasoning about exponential growth right here? What makes this exponential growth right here?
It's over 1.
A is over 1. What makes this exponential growth right here?
Positive.
K is positive. I want to show you something here real quickly in decimals, alright? So, we came up with an exponential formula, two different forms of this exponential growth function. Jump into decimals here. Alright, what I need help with here is this. What function did we come up with on the left side? What was it? 3 point what? Was it 076? Times
0.00422.
I'll raise it to the x. There's a graph of that. I better zoom home on this here, eh? Oops, what's going on here? Did I screw something up there?
No, I can see it.
Okay, let's see what happens here. What was the other one? 3.076 times what?
We just gotta take into
To
account
the
that it's the millions, not
0042.
.004 in this case, x. Oh my gosh. Looks like those two graphs are what, kids?
Same line.
Same line. Now we'll see how long these stay on top of each other, because obviously some rounding is going to change some stuff. Anybody see blue and red yet, or is it all the same color? All the same color, pretty much. Oh my lordies! Wait a second. No way! Isn't that so cool?
So, like 15 billion is when that starts going up, or what number would that be?
Well, this would
That'd
be, I mean, we're
1.1.
talking about T being the number of years since what?
Oh.
I mean, it's increasing. It's just going to take a while for it to increase. Think about it. Our population is only growing at 0.4% each year, not even 1% a year, so pretty slow. Take a while to grow up, won't it? Okay, so let's get back to the notes here, and let's kind of tie up some loose ends that we may have. It says use both to predict the population of Iowa in what year? 2030. So guys, I'm going to have some volunteers do the left and some do the right, but guys, when did we initially start this problem? When was the population 3.076 million? 2012, so that's when time t equals 0. So if I'm predicting population for Iowa in 2030, what do we have to let our t value equal?
18.
Absolutely, 18. So, let's roll on this.
I have a question.
Yeah.
So if you take away the, is it just a coincidence that it's 1.004?
Okay, that's a great observation, Lake. Most times, pretty gosh darn close to that. Like that 1.004, take away 1, you're right there. You're pretty much right on. Now, it's not going to be exactly that amount right there, but it's going to be pretty close most times. So,
Is that a shortcut I can take in
you
a
could,
test?
but I want you to be very, very careful in when doing that, okay?
So check
start happening, especially with exponential decay, that you have to be very mindful of, alright? Got it? Okay, anybody plug 18 in yet?
Yeah, 3.3.
What did P of 18 get us, kids, over here on the left? Anybody do that one? 3.305 million? How about over here on the right? Anybody do the right? We would hope it would be the what? Pretty much the same, right? Anybody got the same? Is anybody punching that in?
Should be the exact same.
Yeah,
3.305 again?
Yeah, don't even check
6.
it. Very
Okay,
precise.
but we're in the park, right? And again, any variance in this is gonna happen simply based on our what? What do we round stuff, exactly, so I'm gonna call this 3.305, so in 2030, what's a good population estimate? Will be approximately 3 point, is it okay if I just say 3.305 million, 3,305,000?
Can you write it out, please?
Absolutely. I'm all about helping people. What do you guys think? You okay with this? Think we can handle a quick quiz right now?